Hello and welcome to a very brief and very superficial introduction to ANOVAs. So, first of all, we use an ANOVA when we have a question that deals with a number by group. We'll say groups. So, if I'm curious about all 32 NFL teams and how fat their linemen are, how fat the linemen are is our number, and the groups are the 32 teams. There are lots of situations in which we care about this scenario. So, for my example today, I'm going to load in some data about a fair, and we will see what's going on. Alright, so I'll just pull up the data for us so we can see what's going on. So I have a few variables here: thrill seeking, with friends, foodie, tradition. Each of those has a value of 0 or 1, making it a Boolean. So you can think about that as, either they think they're thrill seeking or they're not. They went with friends or they didn't. They identify as a foodie or they don't, and they have a tradition connected with the fair or they don't. We then have our number, which in this case is enjoyment of fair. And scores came in at a minimum of 5, a max of 66, with an average of about 33. So in order to run this test, the first thing we need to do is to evaluate one of the assumptions of ANOVA. So we need to load the library car. If you don't have car installed, you would need to type install packages car, and it will pull up a little window for you that says which mirror you want to use, and it'll install it. You only need to do that once. The library car is what brings it into the world. So I'm going to perform our Levine test right now, and Levine test is going to take a number, comma, a group, and if it is significant, which is to say less than 0.05, then the assumption is violated, and we need to come up with something different or some way to handle that violation. So I'm going to do that in this case. My number is from the dataset D and named enjoyment of fair. My group for this case will go with this foodie. Okay, and I spelled Levine test wrong. Spelling matters. There we go. Now, this p-value here is 0.48, which is considerably greater than 0.05, so we're not worried about violating our assumption. If you want to see that again, here it is. And this is the number I'm looking at, 0.48, greater than 0.05, so I can keep going. Alright, my next step is to create the ANOVA model. So AOV creates the model, and I'm going to again do my number, which was enjoyment of food. I really should use shorter variable names. And then we have a tilde here. That's the number next to the 1 with a shift. Enjoyment of food by, I'm sorry, not enjoyment of food, enjoyment of fair. By foodie. Summary of M will produce our p-value, which is considerably less than 0.05. Anytime you see an e in a negative number that's bigger than 2, it's less than 0.05. In this case, it would be 0.130353. Really tiny number. Okay, so now that that's done, we say, yay, it's significant, but what does that mean? Well, first we can look at an effect size. So we can come in and say, all right, I'm going to make a function so that I don't have to do math. That's my function. And what that created is a function named ETA or eta, which is the effect size of this case. So this function takes 2 arguments. It takes m for model, which I named m in this case, and it takes my sum of squares, which right now is 7942. Excuse me. So that gives me an effect size of 0.17, which we would call a small-ish effect, but it is definitely significant. All right. You would then want to know, okay, well, did foodies have more fun or less fun? And that's the kind of post hoc analysis that we would cover in a little bit more detailed video than this. Cheers.